exit ticket from yesterday's notes. I asked everyone to try this before you came into class today. One is set up already with your equivalent bases on the left and right side of the equation. Number 2 is not. It's got some steps we have to take before we're there. Does anybody want to help us walk through what they did on either of those? If you didn't have a chance to try it before coming to class, let's just try to walk through it together. Okay, looking at number 1, what we said yesterday was that when you're trying to solve an exponential, that's when your x is in the exponent. If you have an exponential expression on both sides of the equation set equal, okay, with the same base, that means that the exponents must be equal, because there's no way for that equation to be equal unless those exponents are equal, since they have the same base, right? So what should I set up? What should my first step here be? Yeah, to write out the equation setting the exponents equal. So I know that x minus 3 must equal 2x minus 15. Okay, once you get that set up, this is just a basic pre-algebra question, right? Solve for the variable x. So what do I need to do? Yeah, I'm going to get my x's to the same side and my constants to the other side. It does not matter if that's left or right. You just move the x's to one side and the constants to the other. My personal preference would be to move the x's to where it would come out positive if possible. So I'm going to subtract this single x to the right, since it's the smaller of the two x terms. So that would give me x minus 15 over here. So I've got my x's combined on the right. So I'm going to move my constants to the left. So this 15 gets added, which leaves me with 12. Now remember, I explained to you yesterday, you can always check your solutions by plugging them back into the original equation and making sure that it comes out true. The left does equal the right. So if I were to come up here and plug in a 12, 12 minus 3 is 9. So 5 to the 9th power. And over here, 2 times 12 is 24, minus 15 is also 9. So 5 to the 9th power. So it checks out. You get 5 to the 9th equals 5 to the 9th. Everybody good with that? I also showed you in the calculator in Desmos a trick that will tell you the answer. I asked you to practice doing this algebraically, but then you can use Desmos to check your answers. Use the graph in Desmos. If you type this equation exactly as you see it right here, what will appear on the graph in Desmos? Remember the examples I showed you in Desmos yesterday? What happened when we typed the equation like this, just like we see it? It showed it graphed a vertical line through the x-axis at the solution. So it would, if I were to type this in, it would just graph a vertical line through the x-axis at 12. It's telling you the solution is 12. Okay, so you can check it doing that. All right, number 2 is not set up for us to just jump into this step where we know the exponents must be equal, because our bases are not equal. I only have one exponential expression right now. It's 10 to the x plus 4, and there's a coefficient in front of it. Okay, so I've got to move that coefficient first. You have to isolate the exponential expression. So the first thing that needs to be done is dividing out that 3. Okay, get it over to the other side. All right, so I've isolated my exponential expression, but now when I look at that, I don't have equivalent bases on both sides. So I have to ask myself, can I rewrite one of them to match the other, to be the same base. Can y'all think of a way that I could change 100 to a base 10 expression? 10 squared. 100 is 10 squared. Very good. Okay, so doing it like this, I now get to the point where these exponents must be equal because the bases are the same. So I now set them equal to each other. And I'm ready to solve. This one just needs to move our constant over. We get -2. And you can come up here and double check that. If I plug in -2 plus 4, that's 2. 10, the second power, 10 squared is 100. And then 100 times 3 is indeed 300. Everybody okay with that exit ticket? All right. So what we're going to do today is we're going to go over the formative assessment from Tuesday that was over the graphing and transformation stuff. So I need you to go log into your Aware, and I've got it set to where you should be able to see your results. When you go to My Test Scores tab, you can go and open up that Unit 10 FA1 on graphing. So go ahead and do that. And we're going to take a look at that and just go over any, well, I thought I had it open already. Maybe I don't. Okay, give me a sec. I'll get it open. I do. Okay. All right, so we're looking at this FA number 1 that was over graphing for exponentials. Okay, and you can see your results. Remember, the FA is not for a grade. It was just a checkpoint for you to see where you're at that point. So on Tuesday, this is how much you understood of the graphing questions. Okay, so I'm just going to run through these real quick to go over them with you. Now, at the time you did this on Tuesday, we had not used the terms growth and decay in our notes. So I added those into yesterday's notes, and we talked about what that meant. We said growth is when the graph is exponential growth is the exponential that's increasing. When I say increasing, I'm talking about left to right. So if I were to trace this graph from left to right, it's going up, right? Increasing. And it is an exponential. The exponentials will all be this shape where they level out at an asymptote, at a horizontal asymptote, and then either rapidly increase or decrease. Okay, so this one is increasing, so it is exponential growth. Exponential decay would be decreasing from left to right. Okay, it could look like a reflection of this over the X or the Y. Okay, so it could start up here and come down and level out, or it could be upside down here and come and drop down rapidly. Okay, those, however it is drawn, if it's decreasing, if it's an exponential that's decreasing, that's decay. If an exponential that's increasing, that's growth. Some of y'all were able to get that right just with your powers of deduction. Growth means going up and decay means going down. If you missed it though, don't worry about it too much because like I said, at the time we hadn't talked about those terms, but you should understand that now. All right, here they asked for domain and range. Okay, this is an exponential. This one is decay. It is decreasing from left to right. Okay, and where is it leveling out? Where does it appear the asymptote is here on this graph? At 1, Y or X? That's where Y is 1. Y equals 1 would be your asymptote here. So that is restricting your domain or your range. What is that asymptote stopping this graph from doing? Going left and right or up or down? Yeah, so it restricts the range. Is your domain restricted at all? No, we talked about this. Your domain for any exponential will always be all real numbers. Okay, it's going to go left and right forever, no matter if it's growth or decay, or if it's been stretched or reflected or shifted. No matter what transformation's taken place, if it's an exponential, the domain is all reals. So all of these have the domain as negative infinity to positive infinity, except for C. So you could eliminate C because it has the domain wrong. Okay, but then we have to look at the range. Okay, so y'all just told me y equals 1. That is stopping this. That's the asymptote. So the graph coming down is not going to go past 1. Is that the low or the high of the graph? That's the low. Yeah, the graph is above that. So 1 is the lower parameter. So it goes from 1 and it goes up forever. You can see this arrow indicates it continues. So 1 to infinity. Now, is the 1 included? Do we include the asymptotes in our range? Does it ever reach 1 or does it just approach 1? It just approaches 1. It approaches the asymptote. It never reaches it. So 1 is not included in our range. And how do we indicate if something's included or not included? How does that look when we're writing domain and range? Yeah, that's the parenthesis or bracket difference. So you can see on D, there's a bracket. That means 1 is included. That's wrong. So D and C are both out. So then I'm down to A and B. B is the only one that has 1 to infinity for the range. This one says range is all reals. That is wrong. It does not go past this asymptote at 1. So it does not go down forever to negative infinity. Y'all feel okay about domain and range? Okay. On 3, you were asked where the asymptote was. If you need the visual of the graph to determine that, like we just did with this graph, how we looked at where it was leveling out and said, okay, that was at y equals 1, that's great. Go plug this into Desmos, this equation, and look at the graph and see where it levels out. Okay, you don't have to do that. You can answer this question just based on the equation if you remember that your asymptote will always be at y equals k for exponentials. It's a horizontal asymptote, so it's definitely y equals because it's a horizontal line that goes through the y-axis, okay? And it's y equals k. What is your k value in this equation? Where k is your vertical shift. It's the 3, that plus 3 outside the exponent. That's k. So y equals 3 should have been your horizontal asymptote here. On 4, they asked for the y-intercept. Okay, so you have a couple of options. Again, if you need the visual of the graph, what could you do? Just type this in Desmos and look at the graph. And you can see where does it cross the y-axis. Okay, but you don't have to have that. You should be able to answer this with the equation. A y-intercept happens when x is what? If you're on the y-axis, what is your x value? Zero. If you're on the y-axis, you haven't gone left or right any, have you? So x would be 0. Your y-intercept happens when x is 0. So you just plug in a 0 for x. Anything to the 0 power is what? We reviewed that exponent rule yesterday. Anything to the 0 power is 1. So 1/2 to the 0 power is 1. And then we've got a value of 3. So we have to multiply by 3. And so that comes out to 3. So your y-intercept should have been at 0, 3. You could have gotten that by looking at the graph if you needed to plug this in Desmos and see it. All right, what type of function is below? If x is in the exponent, it's exponential. X in exponent, exponential. Okay, but we need to know if it's growth or decay. Again, we hadn't talked about those terms at the time. So if you missed this at the time, not a big deal. You should be able to answer it now, though. We discussed this in yesterday's notes, and you can look back on them if you need to. We said without a graph, you can tell if it's exponential growth or decay by the base value, what the x power is on. So in this case, 4/5 is our base value. We said you're going to have exponential growth if your base is greater than 1, and you're going to have exponential decay if your base is between 0 and 1. Now, reflections will change that, but there's no negatives here inside or outside, so there's no reflection here. So it follows the rule that this 4/5 is between 0 and 1, so this was exponential decay. Again, though, you can get a visual. Plug this in Desmos and look at the graph. Is it increasing or decreasing? Is all you have to look for. You'll feel okay about the graph ones? Transformation, growth, decay, all that good stuff? Okay, so what you're going to do today is some practice over yesterday's notes, which were... that's not what I want. Here's Delta Math. Yesterday was all about solving. So here your practice today is over solving exponential equations. So if you go and look at your assignments, you'll see this upcoming assignment. This is what you're doing today. It's the Unit 10 Solving Exponential Equations. Okay, it is due by Monday before midnight. Okay, if you have not finished the ALEKS practice on graphing and transformations from Tuesday, you can finish that first today if you'd prefer. Okay, that is due tonight. The ALEKS practice is due tonight, Thursday, before midnight. Okay, this new assignment on solving practice is due by Monday night. Okay, let's see what's under past due. Oh, if you hadn't done the Unit 10 pre-assessment, don't forget to go in and finish that as well. It's at 80% credit through, that's today. It's at 80% credit through today. Okay. I'll, after today, I'll open the corrections for this pre-assessment. So if you weren't happy with your pre-assessment grade, you'll be able to go get half your points back if you do the corrections, and I'll activate those after this 80% deadline. Any questions? All right, the last 10 minutes of class today, we are going to do the second formative. That formative we just went over was the one you did on Tuesday. It was over the graphing stuff. We're going to do one at the end of class today over solving. Remember, these formatives are not grades. They are a checkpoint for you to know how you're doing. If this was the quiz today or the test today, would you know what to do? Would you be able to do it? Okay, so if you end up, and I'll have it set the results to be able for you to view them right away when you finish, so you know how you did. And just know if you don't do so hot on it, you need to be working on this practice before the quiz tomorrow. We have a quiz tomorrow. Okay, and then the test is a week from tomorrow. Okay, when you look at these questions, there's only 10 questions. There's 5 level 1 and 5 level 2, but these are set up. These are questions very similar to what we were doing in our notes. Okay, I'm going to show you one more time. Okay, when you're in the Delta Math, if you're struggling and looking at yesterday's notes isn't helping, you can view a worked example here. You can watch a video here. Okay, I'm going to show you one more time though in Desmos. When you have one like this where the bases are not already matched, you don't have equivalent bases, and you have a big number here that you're like, I don't know what raised to what power gives me that. Use Desmos. Okay, so we know we're trying to match the bases, right? That's the whole point. So we can go and check and say, okay, 36 to some power, I'm going to check and see if I can get this by changing it to a base 36 so that it'll match. So when you do this in Desmos, you would do a base 36 to some power. That's what we're going to try to check. And you can go to the gear and click to make a table out of that. And you can see, okay, 36 to the first power is 36. 36 squared is 1296. And then you can continue that, just hit enter. And there's 36 cubed would give me 46,000 something. So there's no way I'm going to get 7,000 from 36 to a power. Do y'all see that? So that's not going to work. So I come back here and I ask myself, okay, I can't match them at 36. What other base could I change 36 to though? What do I know a base raised to a power would give me 36? Isn't 36 a perfect square? What squared is 36? 6 squared. So I could change this to a base 6. So I need to see, can this one be changed to a base 6? If I can change them both to a base 6, then I'd be able to solve this. Okay, so I'm going to come up here and I'm going to try that again with 6 instead of 36. Okay, make my little table and then check. So we know 6 squared is 36. Cubed gives me 216 to the 4th, 1296. There it is. 7,776. That's this number. So that is 6 to the 5th power. So I can change this to 6 to the 5th to the x minus 5, and this to 6 squared to the 3x minus 4. Okay, so use the calculator, use Desmos to help you figure out how to get those bases matching. Okay, that's not something I expect you to be able to do completely in your head. Use the tools at your disposal. Okay? All right, so I'm going to set a timer. Last 10 minutes of class, we will do this formative over solving. Until then, you're just practicing. You can use your notes from yesterday. You can work with a partner or small group. And of course, you can ask me questions. As a reminder, today is the last day of tutorials for this week. And this week is the last week to do Unit 9 quiz corrections. You may take a correction form with you and work on it from home tonight and bring it back and turn in tomorrow if you need to, if you can't come to tutorials today. But this is the last week for Unit 9 quiz corrections. Also, Unit 9 test corrections can be done. Those must be done in tutorials. If you can't come today, you'll still be able to do test corrections next week. Okay. But I'm here the second half of Lightning Lunch for tutorials, and you can come in to do those corrections for Unit 9 stuff, or just to get help on current Unit 10 things, or if you just need a place to sit and work.